Hello, Pre-Algebra. How you guys doing today? Hope things with the quiz went well these past 2 days. We are continuing talking about geometry. However, today we are talking about congruence and similarity. Again, we're going to be comparing a lot. We're going to be doing a lot with our proportions. So let's get started. Congruent polygons. Again, polygons are shapes. So congruent polygons are two different polygons that have the same shape and the same size. Here's our example. Forgive the drawing, which is not perfect. However, we've got triangle ABC and triangle DEF. And we are told that triangle ABC, and now this has the equal sign with a little squiggly on top, and it's comparing it to triangle DEF. That little equal sign with the squiggly, we've seen it before, but in case you forget, that's our symbol or our congruent symbol. Equal sign with the squiggly, that's called the tilde, T-I-L-D-E. That's the congruent symbol. Now, we're talking about corresponding angles and sides. That's not the less than or equal to, that's corresponding angles and sides. So we're told here that angle A is congruent to angle D. That angle, or that side AB, right? This is using these same two triangles. Side AB is congruent to DE, and so on and so forth with the rest. All of these are congruent to their corresponding sides. Congruent are you congruent with their corresponding side or angle. Corresponding, that's just a mathematical term for like matching, or the one that it compares to, the one that it lines up with. So if we were to take this, and superimpose it, put it on top of the other one, the way that it would match is if D was with A, E with B, so on. Right? If this was turned sideways, it would still be congruent, and we would just have to name its corresponding angle and side. Okay. Moving on from corresponding and congruent, we're talking about similar polygons. Similar polygons are a little bit different because they're the same shape, but they have a different size. So their angles are going to be the same. And I'll show you that in just a second. But the lengths are different. So this has all sorts of different things going on. Let's see. I'm just going to put this right here for now. And we've seen similar things except with triangles. So we've seen triangles that'll say, for example, this line and that line are the same, but this one's different. That's what these angle markings are saying. So it's saying that this angle is the same as this angle, and these two together, and then these two together, right? Again, it's just an indication that of similarity. Now, quickly you'll realize that 6 is not the same as 4. Well, is 6 the same as this 6? Well, it's the same length, but they don't correspond. They don't match up. If we were to take this triangle and, make it a little bit bigger, it's not, this side EF is not going to match up with AB, right? You need to keep it with its corresponding thing. And in this case, it's the angles which line these two triangles together. Since they have the same shape but different size, we call these similar. Now the sign for similar, it's just the tilde, the squiggly. It doesn't have the equal sign. So these two are similar and that they're comparable, but they are not exactly the same. Now, when we have similar polygons, our goal is going to be to find their ratio. So the angles are still congruent, but the sides are not. So they do create this consistent ratio, and that's what we're going to try to find. And finding this ratio, it's just simplifying. So we have, right, AB corresponds with DE, right? They match up, they would line up together. AC and so on and so forth. So what we do is we take that ratio, whatever it is, and then we scale it down. We simplify these fractions. Now, because all of my ratios, all my fractions are the same, it proves angle congruence. It proves that they're similar triangles. Equal ratios or equal ratio proves angle congruence. So because we have the same ratio between this, we know they're similar triangles, right? If they were different ratios, then we would have a problem. Okay. All right. I've got just one more example. With this one right out of the gate, we're told that these two triangles are similar. Again, I've got a picture in just a second. We're told that they're similar, so we're going to use our scale factor, right? That's that similar ratio, and we're going to find our missing length. So in this case, this is a length, and I'm just going to put a question mark here rather than, a variable, because I don't want to confuse you guys. This is what we're trying to find. Now, there's a few different ways we could go about setting up our proportion. The initial one is, no matter what, we're going to need to compare this line with this line. Now, it doesn't matter if the other corresponding lines that I use are ST and YZ or RT and XZ, as long as it's consistent, right? I can't compare these two together and then compare these two together, right? Because they don't correspond. They don't line up. So the first one looks something like this. I've lined up that RS and XY with RT and XZ. Now, as soon as I do this, I can cross multiply, absolutely, and then solve for x, right? But what I'm going to do is I'm going to actually divide my ratio by 2, and then I realize I've got 9 with 9. 9 does equal 9, absolutely. Therefore, x equals my denominator. This missing length, xy, right, I'm going to just call that the blue, just for clarity's sake. So this missing length, xy, equals 6. Right, I simplified this. My numerators match up. Therefore, my denominators need to match up. And this missing length is going to be 6. I could have set up my ratio like this, with this triangle comparing to this triangle, as long as my missing lengths correspond, right? So my numerators correspond and my denominators correspond. And then it'd be more or less the same process, right? I would cross multiply, giving me 18x equals what's that? 108, is that right? Oh, I don't want to do that in my head. 12 times 9, 18, yeah, 108. And then when I divide by 18, I would figure out that x equals 6. Right, again, there's a couple different ways we can go about doing this, but we get to the same place. If you guys have any questions, please, please, please comment below or send me an email. I get to those emails as quick as I can, usually respond in short order. Otherwise, love you guys very much. Bye.